So once again, good morning to all of you. Myself Deepak Upadhyay from Impulse Technology, Gurgaon, Delhi. So thank you for your registration on this hands-on training for the multifunction large-scale DFT and DFPT solver that is rescue from Nano Academy Technology. So in the first session, I will show you some brief presentation and about this Nano Academy technology and what about this rescue software feature I will show you. And in second session, you can do the hands-on. So in the first session, I will show you some brief presentation about this Nano Academy technology, rescue software. So we can start the session. So if we talk about this impulse technology, like what we are and what we are doing here. So this impulse technology is based in Gurgaon, which provide nanoscale material and device simulation software, up to electronics device simulation software, and cloud-based material simulation software. And my most valuable partner, that is Nano Academy Technology. So basically, this Nano Academy Technology is a Canadian-based company who provide the nanoscale material and device simulation software, where you can simulate carbon nanotube, nano ribbons, phase, magnetic junction, crystal, molecule, device. And if you want to work on up to electronics domain, like some perovskite, tandem solar cell, thin film, organic solar cell, OLED, then we have another partner, Fluxit, that work on up to electronics domain. And suppose you have some SPG server that is not good for the DFT calculation, then we can also provide you the cloud-based material simulation software, that is exabyte, that work on clouds. Like you can run your Java on Amazon server, Google server, and you can download your result from this online cloud resources. So these are three major partners that we are presenting in India. So today we have scheduled this hands-on this Nano Academy technology and its product. So I will focus on this Nano Academy technology. So if we talk about this Nano Academy technology, so this Nano Academy technology was founded in 2008 by Professor Hongu, Dr. Zhu, and Dr. Lee from McGill University. So it was developed for molecular quantum transport software that has been used around more than 10 plus years. And now they have enhanced their feature for material development through advanced digitalization and modeling tools. Now they have also addressed the emerging sector of quantum computing revolution, that is QTCAD, for the spin qubit in semiconductors. So we have several unique features and more development are released day by day. So basically they are located in Montreal, Quebec, Canada, originally from McGill University. So this is the company overview. So if we talk about the journey of this software, so in 2001 from McGill University, where Professor Taylor and Professor Hongu, who developed this quantum transport package first, which is also supported by some Northwestern University in 2002. And after several development in 2008, they have laid this foundation of Nano Academy technology. So initially they have developed this nanodical software, which is dedicated for the quantum electronics transport modeling tools, like for the atomistic quantum transport, DFT and NEGF methods. And after that, they have launched this Rescue Plus in 2015. So this Rescue Plus is for the DFT and DFPT solver, and Rescue is for the material simulation. So this nanodical and rescue is a background simulation engine where you can define your DFT parameter, DFPT parameter, NEGF parameters. So apart from this background calculation engine, the user interface is there, so that you can model the structure, you can do some modification, manipulation in your atomic structure. So this user interface is very user friendly. So there is no need to write the script. This user interface will generate your script automatically. So once you define the parameter, then you will generate their script. And even recently they have launched this Rescue Plus. If you want to work on more advanced, more number of atoms, then this Rescue Plus will be helpful. So this is the journey of software. And this is the general overview of our tools. Basically both rescue and nanodicals are two main brand of material simulation tools, and they include a broad range of advanced methods for simulating complex material property at different levels. And also they have tool and toolboxes that can predict the properties. You can prepare your calculation, you can execute a calculation that comes out from the atomistic simulation. So these are two major software that's nanochemistry technology developed. Now this advanced tool are there for building this structure. You can build your crystal structure, molecular structure, device structure, and manipulate these properties. So you can manipulate the Brebbius lattice parameters, alpha, beta, gamma value, ABC value, primitive cells, conventional cells, armchair, zigzag, type of gravity, nano ribbons, nano wires, grain boundary. So advanced tools are there for building this structure along with the user-friendly interface, so that you can set up the DFT parameter, DFPT parameter, electron temperature, cutoff energy, exchange correlation function, key point sampling, iteration control, and also you can do the spintronic calculation. So once you do the simulation, you will get the result, and that result you can visualize from our visualizer. So either you can view in 3D view, 2D view, and 1D view. So here you can see these are the some material properties that you can calculate. Like you can calculate the electronics property, structural property, optical property, thermal properties, magnetic properties, electronics and thermal transport properties, electron phonon couplings. So this is the material property that you can calculate. So, and in the live demo, I will demonstrate what you can do so that you will get this output. So now the bigger application of this software for the molecular structure simulation, molecular material based device structure simulation, surface simulation, 2D material based device structure simulation, complex material like hexagonal, tetragonal, tri-black phosphorus materials, interface between different geometry and different symmetry you can also study, and you can also study the carbon based materials. So this is the bigger application where you can utilize our both nanotical and rescue software. So in terms of accuracy, this rescue also cover all the steps in the accuracy ladder of atomistic simulation. You can define your LDA function, LD exchange correlation, GGA correlation function, meta GGA, hybrid function. You can also study. So like you can define the LDA function, GGA, meta GGA, hybrid Harty-Fock exchange correlation function, and you can also study the spintronics application. Suppose if you want to define the collinear spin, non-collinear spin, spin orbit coupling. So one of the main advantage of this rescue it that it can cover all the accuracy of the electrons in the materials. And in terms of analysis tools, we have a very complete list of analysis tools. For example, you can see this is the example of band structure and density of state calculation with this rescue software.
Visible, huh?
Yes, sir. So one of the main advantage of this software, it can cover all the basic steps that are used in the material atomistic calculation. So here you can see this is the band structure and density of state for the numeric, atomic orbital, and with the real space method. And this is very important part of this rescue, which gives the user the ability to benchmark their simulations, and that result from the different methods like numeric, atomic orbital, and real space methods. And you can also study your symmetry, you can do the symmetry, you can optimize your structure. So we have different methods like molecular dynamic, conjugate gradient. So all this method you can do so that you can optimize your structure, and you can calculate their band structure, band unfolding, density of state, phonon density of state, local density of state, Malkin population, and Vernier function also you can study. So we have a very powerful DFPT toolbox like density function perturbation theory, and this is one of the main strength of this rescue software. So basically, by using this DFPT toolbox, we are able to calculate a variety of material properties that are based on response of materials external perturbation theories, such as dielectric constant, vibrational properties, phonon properties, optical properties, interaction of electrons with the phonons, which is a representative of the electrons for the temperature in the materials. So with this DFPT toolbox, we are able to cover and simulate many of those properties. Like you can calculate the dielectric constant, vibrational mode analysis, low frequency for the optical properties, non-resonant Raman spectra, and you can study their phonon band structure, phonon density of state, boron effective charge, infrared intensities for the complex dielectric permittivity, complex refractive index, energy loss. You can also study the tensor, susceptibility, intensities, and also you can study the EP matrix element. So all these features you can study from this DFPT toolbox. So here you can see this is some example of DFPT calculation, and here you can see this is the example of dielectric constant of the several materials that is calculated with the help of this RESCU softwares. So this is the accuracy benchmark. So here you can see that our result perfectly match with the experimental result, and also with the some numerical and advanced codes. And here you can see this is the performance benchmark of this rescue. So you can see that the we can easily reach the system up to more than 400 atoms, and this is the tough computational problems for other computational atomistic simulation codes. And with this state of art solver rescue software, you can study up to 20k atoms easily. So here we see another example of this DFPT toolbox, and this is the phonon band structure and phonon density of state for the diamond crystal structure. And we see that the calculated result perfectly match with our experimental one, and we can easily calculate the density of state for the diamond supercell structure that contains 216 atoms. So basically you can perform this kind of calculation for every atoms that you have in your systems. And here this is another example of this optical properties for the long wavelength of the hexagonal aluminum nitride. And so you can see we can capture all the atomistic simulation for the main features of the optical spectra for the aluminum hexagonal aluminum nitrides. Like you can calculate their dielectric permittivity for the real and imaginary part. You can also study the refractive index for the real and imaginary part for this optical property calculation. And you can also study the IR intensities for the phonons. So this is the another classic example of this type of information that one can achieve from a atomistic simulation of the materials. So here we see that we can simulate the Raman spectra for a silicon nanowires, and this silicon nanowires created with the different phases like 9R and 3C phases of the silicon. So if you individually study this focus, then you can see that Raman peaks at frequency which are different than the Raman peak for the frequencies for the whole nanowires. So this is the example. So this is the example for this nanowires, silicon nanowires, so that we can simulate it. Here you can see the 9R comes with the smaller frequencies and 3C comes with the higher frequencies for the silicon nanowires. So these are the some Raman spectra that we have simulated with our DFPT toolbox. So if we talk about this rescue software, so this rescue is a very state-of-art general purpose first principle Kohn-Sham DFT package based on the advanced numerical mathematics and parallel implementation. that can predict the material properties on small computer clusters. So it can include the common electronic structure analysis tools and implement a perturbation theory that is an extension of DFT theories, which allow computing all sort of response function like you can do the polarization, phonon band structure, optical properties. So here you can see this is the some key features for this rescue software. So this rescue software is written in MATLAB and C, and it can focus on large scale system. So up to 20K atoms you can easily simulate from this rescue software. And this rescue software can also include the DFPT implementation, density function perturbation theory, like you can do the dielectric tensor, dynamical matrix. You can also study the optical properties like dielectric permittivity, refractive index. You can also study the Raman tools like tensor, spectrum, intensities, and you can also study the advanced functional like you can do the DFT plus Howard terms. And once you simulated this structure, you can also analyze the tools like density of state, projected density of state, local density of state, phonon local density of state, band structure, band unfolding, charge analysis, non-linear optical susceptibility, and you can also study the spintronics application. Like you can study the collinear spin, non-collinear spin, spin orbit coupling, phonon tools, and for the large scale Chebyshev filtering. So this is all about rescue, and this is all about this rescue plus software for the advanced more number of atoms. If you want to study, then this rescue plus will be helpful. So this rescue plus will be written. This rescue plus is written in Python and Fortran, and it can focus on large scale system. So up to 100K atoms you can easily simulate. And this rescue plus comes with the user friendly Python interface where we have these relaxation methods like molecular dynamic, NEB functions, and you can also electronic structure tools like band structure, density of state, projected density of state, Mulliken population, band unfolding, spintronics calculation you can also study. So this is the some brief presentation about this Nano Academy technology and its products. And this is my contact details. So for any futures technical support, you can directly contact through this given number, or you can drop the mail so that we are ready to help you in your research work. So thank you for listening this presentation. Now I would like to switch on the demonstration part. So in the meantime, if you have any queries regarding this rescue software, so you can drop the message in the chat box, or you can unmute your mic and ask me the question.
So, am I audible?
Hello, yes, ma'am.
Yes, I'm Shavna from IT Kharagpur, and I perform these DFT calculations. So, I had one query that you said that we can perform calculations on very huge systems consisting of around 20,000 atoms. So, is that possible on a normal laptop, or do we need NPI for that?
Ma'am, generally we recommend a 16 GB RAM and 16 core processor. But as much as your system is good, you will get the faster result.
Okay, so you mean for supercells for maybe 100, 200 atoms that can easily run on the normal laptop?
Yet normal laptop it can run, but it will take time so that you can simulate. Yes, you can find the band gap values and density of state for the any materials. Yes, graphene of any composite material, alloy, any complex material, you can study their band structure, band gap value, Fermi energy value. So if you talk about the pricing of this rescue software, so this rescue software comes with the multiple option like 1 year, 3 year, and permanent license, and for the single user, multiple user.
So what is the cost of single user 1 year license? Approximately.
So if you go for the single user 1 year license, then price will be 2 lakh plus GST. 2,15,000 plus GST for the single license 1 year. And for the permanent license, 5,50,000 plus GST for the single user permanent license. So now I can open my software. Yes, ma'am. Tell me.
Hi, sir, this is Ankita from IT Panagar. So, sir, actually, I'm from experimental background. So, I do have only little knowledge about the DFT or the theoretical studies. So, would that be okay, or is there a prior requirement?
Ma'am, your voice is a little bit low. Can you speak loudly?
Uh, Sir, am I audible now?
Yes, you can.
Sir, actually, I'm from experimental background.
Okay.
So, is there a requirement of a prior knowledge in the theoretical background for this hands-on training?
Yes, for theory part, you can visit our official website. This official website you can visit nanoacademy.com, and then you get all these theories and documentation. Here you can see this is the document and tutorials, and this is our RESCU softwares.
Oh, all right, sir.
So
Thank you.
here you can see this is the theory and tutorials are there. So whenever you get the time, so you can visit our website, then you will get more familiars.
Oh, okay. Thank you, sir.
So here you can see this software is downloaded in my C drive, and this is the device studio file. And the software is located in the bin folder. Here you can see this is my bin folder, and this is the device studio application file. So I hope everyone has been downloaded this device studio graphical user interface, and they have already pasted this license. Here you can see this license we have pasted in this bin folder. So
Am I
once,
audible, sir?
Hello, sir.
yes, ma'am.
Hello, sir. Is it compatible with Mac?
No, we are finding difficulty in downloading this software. I have mailed you.
You have mailed me
Yes,
already.
sir. We are also finding.
We are finding difficulty. So please solve this problem.
Okay, no, so so for downloading this software, here you can see this mail I have already forwarded. So you can click on this link, and then you will get this interface. So simply you can click on this download option, and here you can click on this download anyway. So once you click on this download anyway, then it will start the downloading. Here you can see, you can select the location. Here you can see it has started the downloading. So what I have downloaded already, so I can show you for the more procedure. Like once this software will be downloaded, you can go to this download folder, and here you can see this is the zip folder. You can select this folder, right click, and select this extract file. So you can click on this extract file, and you can extract this file in the C drive. So you can select this C drive, and then you can click on this OK. Then it will start the extracting the file. So once the file will be extracted, then you can go to this mail file, and here you can see this is the license file. This file you need to download. Here you can see the license has been downloaded. This is the license. You can copy this license and then go to this C drive, this device studio folder, this bin folder, and here you can see, you can click Control V. You can see the license is already there. So you can click on this, replace the file in the destination. So once you do this, then your software will be installed. And then you can click on this device studio application file. and you can click on this OK. Here you can see the validity of this license for the 1 month, and the software will be installed successfully. Here you can see the license has been installed. So you can follow the same procedure and that I saw, so that you will get. And also I have sent you the videos. Here you can see.
Sir,
Yes, ma'am.
sir, I have already installed the software yesterday, and when I'm opening it now, it again asks for extract files. What I have to do now? Yesterday it was
Yes,
working, now
sir.
it
Same
again
problem is occurring with
asks
me
for
also.
extract files.
Yes, sir. Yesterday I also.
So you can share the. Yes. Hello.
The same problem with me also, sir. Yesterday I was able to open
Yes,
the
sir.
software, but today morning it is asking for again for the extraction.
So today morning, which file you are opening, in the download folder or in the C drive folder?
Uh, but how yesterday last night I opened the file as the same file, and it was open, but today morning it was not opening, and again it is asking for extraction the file.
So one thing you can do. So you can share the any desk at TeamViewer ID and password in the WhatsApp group, and we will solve the
Okay.
issues so that we can take the access and we can solve the
Uh,
issues.
Sorry, sir. Which ID password?
Remote access, like either any desk or
Okay.
TeamViewer.
Okay.
Hello, sir. Can you hear me?
Yes, ma'am.
Is it compatible with MacBook?
Yes, this software is also integrated in the MATLAB. So some of the output will open in the MATLAB. So I have already forwarded you the
No,
procedures.
not MATLAB. MacBook
Yes,
Pro.
yes.
I'm saying Apple laptop, MacBook.
Ma'am, can you repeat?
Is it compatible with MacBook, Apple laptop?
Yes, this software is also you can install in the Mac, Windows, Linux operating system.
Hello, sir.
So in Mac, where will C drive is not?
No, in the Mac there is another procedure. So you can go out here. You can see. So installation procedure are already there. So this procedure is for the Windows, but if you want to install it for the Linux and Mac OS, then we can forward you the another procedure so that you can install. So now I can switch on this demonstration part. So this is the bin folder, and this software is located in this bin folder. So this is the device studio application file. Now I can open this file. So once you open this device studio application file, this interface will open. So I would like to start from this scratch. So create a new project. Okay. Here you can enter the project name. and then you can choose the location where you want to save the project, and then you can click on this save option. Here you can see this is our project name. So this is the property explorer, project explorer, where the input and output file will be shown. And this is the properties explorer, where the property of a whole structure or individual atom you can see. And this is the job manager. So in the file option you can see, in the menu bar you can see this is the file option. And in the file option you can see this is the for creating a new project. You can open your existing project, you can save your project, you can design your new device structure, crystal structure, molecule structure. And this is the import option. So this software have two options to import the materials. So either you can import the material from this local database, or you can import the material from this online database. So import locally in the sense this database is already existed in this software. Here you can see this is our device studio file, and this is the material folder. So these are the some material folder like 0D material, 1D material, 2D material, 3D material, and some organic material are there. So this is the 0D materials, some molecules, amorphous and crystalline are there. This is the amorphous, this is the crystalline. So this is the 0D materials, and this is the 1D materials. So in the 1D material you can see this is the nanotube folder, and this is the nanotube input file. So this is the various combination of crawl vector and an m value are there. So this is the nanotube, and this is the 2D materials. So this is the novelty materials. Here you can see this is the arsenic, bismuth, black phosphorus, hybrid boron nitride, and this is the graphene. So this is the 2D materials. This is the 3D materials. In 3D material you can see this is the conductor, insulator, layer materials, magnetic materials, metal oxide, novelty material, and semiconductor is there. So this is the conductors, pure metals. This is the insulators. This is the layer materials, and this is the magnetic materials. This is the metal oxide. This is the novelty materials. So in the novelty material you can see this is the perovskite based materials. This is the topological insulators, and this is the half value metals. So these are the novelty materials, and this is the semiconductors. So this is the 3D materials, and this is the organic materials. So in the organic material you can see this is the crystal and this is the molecule. So these are the some crystals, and this is the molecules. So the conclusion is that this is the material database that exists inside the software. So either you can import from this database, and here you can see this software support this file format. So this file format you can easily import in our device studio, and then you can study either from this RESCU, either from nanodical software. So here you can see this is the .szw, .xyz, .cif file, .xsd postcard file, contar, scf.input file. So all this file format you can easily import in our software. And if the material is not present in this local database, then you can import your material from this import online option. So here you can see this is the import online. You can select any element. So first you can enter the chemical formula. Like here you can see this is the SiO2, silicon dioxide, and then you can click on this search option. So you can see SiO2 with different combination with different space group has been searched. So as per your need, you can select this structure, and then you can click on this add option. So any structure you can select, and then you can click on this add option, then it will be loaded. And if the material is not present in the local database, either in the online database, then you can create your material from this crystal builder and molecule builder. So if we talk about this crystal builder, so this is the crystal builder that will help you to build your simple structure, complex structure, alloy, any complex structure you can build from this crystal builder, because we have a very space group. Here you can see 1p1, 2p1, 3p2. So this is the complete list of this space group, and according to this space group, the Brebes lattice will automatically selected. And you can also change their ABC value, alpha, beta, gamma value. You can add any element from this plus option here. You can see this is the plus option, and this default carbon atom is there. So if you want to change this carbon, double click, then this periodic table will open. So from periodic table you can select any element. Like if you want to create a gold crystal structure, so you can select this gold element, then you can select this OK option, and then you can change their fractional coordinate point, ABC value, space group. So if you want to change any space group, so I want to select the face center cubic structure. So here you can see this is the face center cubic structure, and if you want to change the ABC value, so as per your research work you can change. Like here you can see this is the A 0.4.07 angstrom, and if you want to change their fractional coordinate point, then you can enter their values.
Sir, excuse me, 1 minute, sir. How can we add elements here?
So here you can see this is the plus option. You can click.
Yes, sir.
And you can
It
select
shows,
any fractional coordinate point.
but in our
And this
laptop
atom will
it
be,
shows only 000, sir.
yes, you can select 000. Then the
Okay.
default carbon atom will be selected.
Okay.
In the element option, you can see default carbon atom will be there.
Yeah, sir.
So double click on carbon, then periodic table will open.
Okay, sir. Fine. Thank you, sir.
And if you want to remove any element, so here you can see this element I want to remove. So you can select this minus option, then it will be removed. So n number of atom you can add from this plus option, and then you can show the primitive cells, conventional cell. So here you can see this is the primitive cells. Select this preview option. So this is the primitive cells for this gold crystal structure. And if you want to show the conventional, so this is the conventional. Select this preview option, and this is the conventional cells for this gold crystal structure. So any structure you can select, you can preview, then you can click on this build option. So this is the crystal builder that I have created from my crystal builder option. And if we talk about this molecule builder, so here you can see this is the build option, and this is the molecule 3D builder, and this is the molecule 2D builder. So first I can select this molecule 2D builder. So this is the molecule 2D builder that will help you to create your molecule, either simple molecule, complex molecule, organic, inorganic molecule, any molecular structure you can create from this crystal builder. In the left hand side you can see various fragmentation and various bond options are there. So as per your need you can select this structure. Like if you want to create a benzene structure, so first I would like to select this ring segment. Here you can see this ring segment has been loaded, and if you want to draw the single bond on the top of this option, so you can select this single bond. Here you can see this is the draw single option. So you can select this carbon, carbon, and then you can draw the single bond like that. So you can see this is our structure, molecule structure. But as you know, in the benzene structure, only hydrogen is there. So we need to change this CS3 with the hydrogen atoms. So for this, I can select this choose element option. And from this periodic table, I can select this hydrogen atoms. Here you can see this hydrogen has been selected. You can cancel this one. And then you can replace this CS3 with the hydrogen atoms. Here you can see this is the only hydrogen atoms. So this is our benzene molecule C6 molecule structure. So once you created your structure, you can click on this apply data. Then your structure will be loaded in our dashboard. So here you can see this is the apply data option. You can select, and this structure has been created here. In the toolbar, you can see this is the various force field calculation like UFS, GFS, chemical. So as per your need, you can select the force field calculation, and then you can study their properties. So here you can see this is the GFF force field calculation. So this is our benzene molecule structure. And if we talk about this molecule 3D builder, so you can see this is the molecule 3D builder. Here you can see this is the periodic table. So you can select any element like this is the carbon atoms and their various fragmentation. Like this is the single atoms and this is the trivalent, tetrahedral. So as per your need, you can select the fragmentation and you can choose anywhere. Like here you can see this carbon tetrahedral fragmentation has been selected. So any structure you can create from this molecule 3D builder.
Hello, sir.
Yes, ma'am, tell me.
So can we input from the online to mol file and CIF file?
Yes, CIF file you can also import. Here you can see. You can select this import local.
Okay, sir.
You can select your file, CIF file. Here you can see this software support this CIF file. So you can select the file. Here you can see some of my CIF file is there. So you can select and then you can click on this open option.
Okay, sir. Okay.
Here you can see this structure has been loaded.
Okay, sir. Thank you, sir.
So this is the molecule 3D builder. And here you can see this is the modify bond. So if you want to modify the bond between any atoms, so you can select this modify bond option and then you can select the atoms. Like here you can see this is the first, this is the second atoms, and then we will get this interface. So this is the modify single bond, this is the double bond. Here you can see this is the double bond, this is the triple bond, this is the resonance one, and this is the half metallic bond. So as per your need, you can select the bond and then you can click on this OK option. So you can also modify your bond. And if you want to modify the angle, so here you can see this is the modify angle option. You can select any element. So either you can enter the value here. So here you can see either you can enter the value here or you can drag and drop this option. Then you can modify the angle. And if you want to fix this first atom, here you can see this is the rotate group and this is the fix option. this one, this atom 1 will be fixed and 2 and 3 will be rotate. Here you can see 1 is fixed and 2 and 3 will be rotate. So if you want to fix this second atom as well, then only third will be rotate. So from this modify angle option, you can modify the angle between any atoms. And here you can see this is the modified dihedral, like the angle between 4 atoms. So you need to select the 4 atoms, and then you can modify their angle. So this is the molecule 3D builder. So if you want to import your molecule, so here you can see this is the import option, and then select your molecule. Like if you want to import this benzene molecule, you can select, then you can click on this open. Then this benzene molecule has been imported in our molecule 3D builder.
Excuse me, sir.
So if you want to create a tylene molecule structure, so first I can replace this hydrogen with the oxygen carbon atoms. So I can replace this hydrogen with the carbon atoms. So I can select this add option, and then this select carbon atoms, and I can select single atoms, and then I can press on the hydrogen, then it will be replaced. Here you can see the atom has been replaced. So this is the hydrogen and this is the carbon.
Excuse me, sir.
So for the tylene molecule structure, yes sir, tell me.
Sir, just want to know that how this software is different from quantum ATK, that only. So I just
Yes sir, this is the
want to
competitor
understand.
of the quantum ATK.
Uh,
Like here
but
you can see
how?
we have this, sir, I can, like this is the nanodical and that is a competitor. So as you know, in
Okay.
the quantum ATK, only 3 pro device structure is you can simulate, but in our nanodical
Yeah.
software you can simulate up to 6 pro device structure. So like here you
Yes,
can see
yes.
this is the, yes, this 6 pro device structure you can simulate, like left right structure, left center right structure, bottom and top structure, bottom center top structure, front and back structure, front center and back device structure. So this 6 pro device structure you can easily simulate from our nanodical software. That is the competitor. And
Okay.
also this nanodical has the benefit of converting to device bending of device structure. So here you can see this is the bending of device. So once you
Oh.
create a device structure, then you can bend your device at any angles.
Okay. For example, if I am able to prepare a flexible supercapacitor using graphene sheets,
Okay.
so can we study the bending or like folding properties through this software? What you are telling
Yes, sir. Yes, sir.
right now?
Bend unfolding, device bending, you can also study.
Okay. Okay. Yeah, it's good. Good. Please, thank you. Please carry on.
So for making a tylene molecular structure, so we need 3 hydrogen atoms that is connected with this carbon atoms. So I can select this hydrogen atoms and 3 times press here on this carbon atoms. So this is our tylene molecular structure. And if you want to create a 2,4,6 trinitrotylene, so we need a nitrogen group. So first I can change this hydrogen so I need to change this hydrogen with the nitrogens. So this hydrogen, and this hydrogen. So I can select this add atom option. Here you can see this is the nitrogen, and select this single atoms, and you can replace like that. So for the nitrogen group, we need oxygen that is connected with this nitrogen atoms. So first I can select this hydrogen atoms, and I can add two hydrogen atoms with this nitrogen, two hydrogen atoms here, and two hydrogen atoms that will be connected with this nitrogen atoms. So for the nitrogen group, we need to change this hydrogen with the oxygens. So one thing we can do, we can go to this add atom option, select this oxygens, select this single atoms. Here you can see single atom has been selected, and then you can replace like that. So you can press on the hydrogen, then it will be changed. So this is our 246 trinitrotoluene molecule structure. So any complex structure, simple structure in organic molecule, you can create from this molecule builder. And once you created your structure, you can click on this apply data. So here you can see our trinitrotoluene molecule structure has been loaded in our dashboard. So if you want to import some materials, so here you can see this is the import option. So I can import some materials, like this is the import local option. This is the 2D materials, and this is the graphene. So I would like to import this graphene from my local database. So this is the graphene, and for simulating any structure, you can select this simulator. So this is the simulation engine. Like this is the nanodical, that is for the DFT and NEGF. Like you can do the material and device simulation from this nanodical software. And if you want to do only material simulation, then this RESCU Plus will be helpful. So this is for the DFT and DFPT method. Here you can see we can define the DFT parameter in this SCF calculation, and we can define the DFPT parameter from this DFPT options. And this is the nano scheme for the tight bonding model of nanostructure. So I can select this RESCU, select this SCF calculation. So this is the consistent field calculation for this graphene structure. Here you can see we can define the basic settings, we can define the simmering sigma, we can define the resolutions, we can define this method, like this is the real space, and this is the linear combination of atomic orbitals. So these two methods are there. So any method you can select, and then you can click on this generate file option. Then their input file will be generated. So also you can select this one Newman file option. You can select the K-point sampling. You can change their iteration control, like you can define their tolerance, charge density, total energy. You can see this is the basic settings, like this is the arrangement. And this is the Howard atoms. So this is the LDA plus U, that is for the Howard atoms. So Howard in this sense, some SPDF combination are there. Like here you can see, this is the SPDF combination. So this is the double zeta polarized, and here you can see this is the atomic database, and the user defined database is already there. So user can define your own database from your existing database. So here you can see this is our device studio, and this is our neutral atomic database. This is the general file option. So you can see various neutral atomic database file are there. So as per your need, you can select either single double zeta polarized, any file you can select, and this is for the specific element. Like here you can see this is the LDA, and this is the double zeta polarized.nad file. So this is our neutral atomic database that already there. And if you want to study the spintronics application, suppose collinear spin, general spin. So here you can see this is the collinear spin. So this is the carbon atoms and their maximum value. This is the polarization value. So this is the general spin. Here you can see this is the carbon and this is the maximum phi and theta value. So this is for the polarization. And if you want to study the spin orbit interaction, so you can select this option. Then this spin orbital interaction will be enabled. So I am taking this collinear spin, and so once you define the parameter, you can select this generate file option. Then your input file will be generated. So in the left hand side, you can see this is the project explorer where our output and input file will be there. So this is the input scf.input file. So if we talk about their script, so you can see this is the open with, and this is the script for this graphene structure. Once you define the parameter, click on generate file. This software will generate their script automatically. So you can see what parameter we have defined. So all the parameters are there. Here you can see this is the collinear spin, and this is the carbon atoms. And for their fractional coordinate point, you can see this is the atom.xyz file. You can open with, and this is the Cartesian coordinate point for this carbon atoms. And for simulation, you can select this csf.input file and select this run option. So for running any input file, you can select the input file and select this run option. So suppose if you want to run the Java on parallel, suppose 5 core, 10 core, 15 core, so there is no limitation of core. You can define up to 128 core. So in my computer, you can see 12 core is there. So once you define the parallel core, then you can select this run option to run this job. In the job manager, you can see my scf.input file is in the running condition. So in the meantime, if you want to analyze the parameters, so you can select this simulator, select this rescue, then go to this analysis part. Here you can see this is the analysis with the help of DFT calculation. So this is the density of state and their parameters. So here you can double click on the density of state, then it will be selected. And then this is the density of state parameters. Like you can define their K point sampling, you can define their energy range, you can define their number of energy point, you can select the K point sampling method. Like this is the Fermi direct, Gauss method, tetrahedral. So all these methods are there. Anyone you can select, and then you can define their parameter. Like you can define their sigma, you can select this impediment, and this is the projected density of state, and this is the local density of state. Here you can see this projected density of state has been selected. And if you want to select this local density of state, then you can define the energy for the local density of state in the unit of electron volt. So I am taking this default density of state value. You can define some K point sampling. And here you can see this is the band structure. So this is the band structure that has been selected, and this is the band structure parameters. So this is the symmetry K point. And if you want to show their Brillouin zone path, so here you can see this is the path, and this is the Brillouin zone path for this graphene structure. You can also change your K point sampling as per your needs. So if you want to add more K point sampling, here you can see add option are there. So here you can see this is the number of K point total 400. So as per your need, you can select the analysis input file, then you can generate their input file. In the job manager, you can see the scf.input file has been completed. So again, we need to run this density of state input file and this band structure.input file. So this is the density of state and this is the band structure. So in the job manager, you can see I have run this input file in the queue condition. Like when this density of state will completed, then this band structure will start automatically. So in the queue condition, you can run multiple input file. And if you want to show the procedure of simulation, so here you can see this is the rescue log.output file. So you can open this file and here you can see this is the beginning of self-consistent calculation. So here you can see step-wise step procedure are there. Here you can see this is the step first and their values. So this is for this SCF calculation. And here you can see this is for the density of state calculation. So again, step-wise step procedure are there. And here you can see this is the band structure calculation. Here you can see this is the collinear spin. Here you can see this simulation is running. Our density of state simulation has been completed. So for showing their output value, you can select this file and select this open containing folder. Here you can see this is our project location. Here you can see this is the device studio project file. This is our project name, hands-on rescue. This is the graphene folder and this is the rescue crystal folder. Here you can see this is our result folder. Here you can see this is the density of state output file in the text format. So for showing their graph, you can select this simulator, select this rescue, go to this analysis plot. You can select your project location. Here you can see this is my project location. This is the graphene folder. This is the rescue crystal folder. And this is our result folder. Here you can see this is our density of state. And this is the really space density. So this is the density of state. I can select. And then you can select this open option. Here you can see band structure has been completed. And their output has been generated. So first I would like to select this density of state. Then select this open option. And here you can see this is our density of state for the spin up calculation. So this is the density of state with respect to energy. So this is the density of state for the spin up calculation. And if you want to show the spin down, so here you can see this is the spin down calculation. And this is the both spin up and spin down. And if you want to export this raw data, so here you can see this is the export option. And then select the format, like which format you want to export, like PNG, JPG, BMP, PDF. So any format you can select, like this is the JPG. You can select the location and then you can select this save option so that you can easily export your raw data in any format. So here you can see this is our density of state. And if you want to show the band structure output, again you can select simulator, select this rescue, then go to this analysis plot. Here you can see this is our band structure. So this is the band structure for this graphene crystal structure. So this is for the spin up. Here you can see this is the spin up, this is the spin down, and this is the both spin up and spin down band structure. So this is our conduction band, this is our valence band, and this is our Fermi energy.
So what if
So
we want to set the Fermi energy below zero level? Is that possible? How to do that here?
so for showing their yes, so for showing their value, output value, you can open your MATLAB. You can see this is the MATLAB, and then you can import this graphene file. You can import in the MATLAB, so that you will get the output values like their Fermi energy value, band gap values, all this value you can get.
No, no, sir. I was asking that what if we want that the valence band should end at zero level and the conduction band should start above that? Can we set that in this software itself?
Can you repeat your questions?
Sir, I'm saying that if we want to plot the band structure in such a way so that the highest level of the band, the valence band is at zero, and then the conduction band starts after that.
So whenever you define the parameters for the valence band, conduction band, their Fermi energy, like once you define their input parameter value, and according to this value you can get the output. So because I have taken the default parameter, so that's why this structure I will get. So whenever define
Uh,
the accurate parameter, then you will
Excuse
get
me.
the accurate result.
Yeah, I have a question, please.
Yes, ma'am.
Can we run this on a remote machine?
Yes, remote machine you can also run. Here you can see this is the machine setting options, and then you can select your machine. Like if you want to add a new machine, this is the new option. Then you can set up their like host ID, port. You can define their username, password, and then you can add this machine. Here you can see one machine has been added, so you can select this machine has been loaded, and then you can simulate this structure. Here you can see this machine has been selected.
So if I want to run some other DFT softwares, then I can create the input for that also.
Yes, ma'am, you can create. So
How
for
the
showing their
data
output
for
value,
other DFT softwares can be generated?
yes, ma'am.
How the input file, structure file for other DFT softwares can be created using this GUI?
1 second, ma'am, I can show you. Like here you can see this is our graphene, this is the rescue crystal, and this is the result folder. Here you can see this is the graphene band structure.mat file, and this is the graphene density of state.mat file. Here you can see this is our data. This is the band value, this is the band gap value, So from this MATLAB, you can get their output value.
Can you just tell me that through this GUI, can I create the input structure file for any other DFT software?
One second.
Actually, I would like to add a comment to the question asked by Dr. Silva. For other softwares, I think the input file will be specific to that software. So probably you can just minimize the parameters that you need using this software, this rescue, and then use these parameters in the input file of the other DFT software you're looking for.
No, no. What I meant was that can it create the files for say VASP in that format or
Here
VN2KC
you
or
can see,
Quantum Espresso?
ma'am. Here you can see, like this is the graphene structure, and if you want to create a Gaussian file, so here you can see this Gaussian is enabled, and their input file you can generate. So you can select their input parameter you can define, and then you can click on this generate file. Here
So
you can
only
see.
Gaussian and NWChem are there which are enabled, or any other additional can also be added
You
to
can
this.
also create for the WASP, LAMS, Obito, Quantum Espresso.
Okay.
So for this software, you can generate their input file.
So will I be able to run a VASP program also through this, or will I be able to only generate the input
No,
file and then
no, ma'am.
run it separately?
You can generate their input file. Only you can generate their input file.
Okay. So
Because
rescue
for
will be
running the
running.
program, you need a license.
No, no, if license and all is there, through this GUI, can I
And
run
we have given
create
you the
first?
license.
Pardon?
And we have given you the license for this rescue software, not for the Quantum Espresso, Gaussian, WASP. So only,
Yeah, yeah, I
only
understand.
their
I
input
understand.
file.
What I'm asking is that if I have the license for these other softwares, can I run through this GUI those programs?
Yes, ma'am. Yes, ma'am. You can run.
Okay, thank you.
So for this, there is some settings. So you can do the setting. Then you can run their input file. So let me finish this session, and in the end of the session, I will get you some time. So that time you can ask your queries.
Sir, after this training program, recorded video is available, sir?
Yes, ma'am. Video are available.
Okay, thank you, sir.
So this is the band structure and density of state calculation with this DFT theory, density function theory. So if you want to simulate this
Sir,
DFT, yes, ma'am.
can you please show the structure of the doping elements in the graphene structure?
Yes, ma'am. Doping you can do. So just wait. I am showing you.
Okay, sir.
So for the DFPT calculation, you can select any structure, go to this simulator, select this rescue, then select this DFPT simulation. And if you want to relax your structure, so for the optimizing this structure, we have relax option. So if you want to optimize any structure, so you can define their method, either Cauchy-Newton, stepped descent, conjugate gradient, any method you can select. You can define their input parameters, and then you can create on this generate file option. Here you can see the relax.input file has been generated. So optimization is also possible. So I am showing you some DFPT simulations. So here you can see this is the rescue, this is the DFPT. So So this is the density function perturbation calculation for this structure. So this is the basic settings. In the task, you can see this is the phonon band structure calculation, phonon density of state calculation, phonon band structure and phonon density of state calculation, optical property calculation, and Raman property calculation. So as per your need, you can select the calculation. Like if you want to calculate the optical property, then you can select this optical property calculation. Here you can see it has been selected, and this is the optic parameters. This is the damping factor, electric field directions. So if you select this Raman property, then the Raman parameter will be there. So this is the Raman parameters: damping factor, key point Cartesian, income photon polarization, outcome photon polarization, income photon wavelength in the unit of angstrom, and also you can define the temperature. So any parameter you can select, and then you can define their value. Either you can change their simmering sigma resolutions. You can also define the SCF methods. You can here you can see this is the exchange correlation function like LDA, GGA, and hybrid function is also there. So for the hybrid function, you can select this RESCU, select this SCF calculation. Here you can see this is the LDA, GGA, meta GGA, hybrid function is there. So this is the DFPT calculation for this optical property calculation. So you can define their values. This is the iteration control. Here you can see this is the SCF parameter, and this is the tolerance, charge density, total energy, and this is the DFPT parameters. You can define their methods. Either any method you can select, like Sternheimer, Chebyshev filtering. So these two methods are there. Any method you can select, and then you can generate their input file. So once you generate their input file, in the project explorer you will find scf.input file, dielectric.input file, phonon.input file, and optical.input file. So from top to bottom you can run all the input files. Like this is the scf.input file, you can run. This is the dielectric, this is the phonon, and this is the optical.input file. And if you want to show their script, so this is the open with, and this is the script for this self-consistent for this graphene structure. So here you can see what parameter we have defined. So all the parameters are there, and this is the help of DFPT calculation. You can see scf.input file has been completed, dielectric.input file has been completed, and this phonon.input file is in the running condition. So once this simulation will finished, then we will get the dielectric optical properties. Like you can show their refractive index, this phonon has been simulated, and now this optical dot input file is in the, it is also completed. And for showing their graph, here you can see this is the input folder and this is the result folder. So this dielectric dot output file has been generated. Here you can see this is the mat file. So if you want to show the graph, so one thing you can do, you can select this open with, and here you need to write the script RESCU. You can copy the location, Control C, and you can Control V here, and you can include .mat file. So you need to write this script. Then you can select this save option so that the input file will be saved. Here you can see this file has been saved. And again you need to run this file. Here you can see the simulation is running. So once this simulation will finished, you will get the output file. You can see this is our graphene and this is the graphene copy folder. So this is the RESCU DFPT. So here you can see this is the graphene and dielectric.mat file, and this is the optic.mat file. So this is our result folders. Here you can see all this data are available. This is the optic value. Here you can see this is the IR intensity frequency. This is the IR frequencies, and this is the IR intensities. This is the dielectric frequencies. And this is the dielectric function. And if you want to simulate the Raman spectrum, so I can import some materials like this is the pure metals. And this is the silicon. So for simulating any structure, you can select simulator, select this RESCU, then select this DFPT. And in the task, you can select this Raman properties calculation. You can define their input parameter as per your research work. And then you can click on this generate file option. So once you generate their input file, you will find SEF.input file, dielectric.input file, phonon.input file, and Raman.input file. So you can run all the input file from the top to bottoms. So once this simulation will finished, you will get the Raman.
Excuse me, sir, can I ask a doubt?
Yes, ma'am.
So actually, I was trying it with one of the file which was imported online. So I'm not getting the results in the Word format. So what they're saying is that a domain keyword is missing and could not be read from rhu.in. So what would be the reason for that?
Ma'am, can you send that screenshot in the WhatsApp group?
Sure, sure. Yeah, I shall do that. Thank you.
Yes, okay. This CSF input has been completed. This dielectric has been completed, and this phonon.input file is in the running condition. So in the meantime, I can show you more properties. Like here you can see, if you want to show their face center cubic structure, body center cubic structure, either you want to create a heterostructure, then you can select this redefine crystal. Here you can see this is the face center cubic structure, and this is the body center cubic structure. So this is the VFCC for the silicon structure. And if you want to show the body center cubic structure, so this is the body center cubic structure. So I have selected this face center preview, and then I would like to click on this build option. Here you can see this Raman has been completed. And for their output, you can select this open with, and here you can write the script for plotting the graph. You can copy the location, and you can include .mat. So this input, this script you need to write, and then you can click on this save option, so that the input file will be saved. And again you need to run this Raman.input file. Here you can see the output has been generated. So here you can see this is our silicon folder. This is the RESCU DFPT folder. This folder is there. Here you can see this is the RESCU DFPT folder, and all the input and output file will be there. So here you can see these are the input folder, and this is the result folder. So this is the silicon Raman polarized graph. So this is the Raman intensity versus Raman shift graph. So this output is for the silicon structure. So this is the Raman polarized graph. And if you want to show the Raman averaged graph, here you can see this is the peak value. So this is the peak value. So this is the Raman spectrum. So one second. So in the task, you can select anyone: phonon band structure, phonon density of state, phonon band structure and phonon density of state calculation, optical property calculation, and Raman property calculation. So you can generate their input file. You can run this all the input file, and for the Raman you can write this script. So this script you can write for the Raman output, and for the optical you can write this script. And for the phonon band structure and phonon density of state, here you can include BS for the band structure, and you can include DOS for the density of state. And you can save, and then you can run this input file again, so that you will get the output graph. So this is the face center cubic structure for this silicon. And if you want to create a surface and slab for this structure,
Sorry, sir. Can I ask a question?
yes, sir. Tell me.
Can you please show the Raman output graph in MATLAB? I think.
Here you can see this is the Raman plot.
Yeah. So, is this right for in the case of silicon?
Sir, as you in the input file you can see. One second. I have taken the default input parameters.
Okay.
So once you define their input parameter accurately, then you will get the accurate result.
But defaults are like for optimized parameters that you will get a theoretical value or theoretical peak value. position. So, but its position beyond 700, I think.
So here you can see their theories. This is the rescue. This is for the DFPT.
Yes, sir.
This is the Raman inspector.
Uh-huh.
So all the theories and equations are there. So you can visit this website.
Mhm. Is there any graph here? For example,
Yes. This is for the boron nitride.
okay, I will check. Thank you. Please continue.
Okay. Okay. So if you want to create a surface and slab, so here you can see this is the surface and slab option, and we have the Miller indices value. So a scale value you can define as per unit. Any combination you can select, either 100, 101, 111, 110, 111. Any combination you can select. And for creating a slab, you can enable this option. Here you can see this slab option has been included, and you can increase their thickness, their vacuum as per your needs. So here you can see their thickness has been increased, and if you want to create a vacuum inside this structure, so any combination you can select.
Can
So
we
here you can see this is
create
the
a
one.
bi-layer or a multi-layer system also?
Yes, multi-layer option you can also study. I can show you like. So this is the surface slab. And if we talk about this, here you can see if you want to create a graphene nano ribbons, nanotube. So this is the graphene nano ribbons. Here you can see this is the carbon atoms on the site A and site B carbon atoms. This is the bond length and this is the Kroll vector. And an M value you can define. So here you can see this is structure with the hydrogen atoms. So here you can see this is the passivation. And if you want to increase this length in this transport direction, so you can select this field option, select this redefine crystal, and you can redefine your structure by expressing the new cell vector UVW as a linear combination of ABC. So in any direction you can increase. So I would like to increase in the transport direction, that is C. So here you can see this is the 15 times in the transport direction. Here you can see this structure has been increased. So in any direction as per your need you can increase, and then you can click on this build option. So you can see this is the single layer. So if you want to create a multiple layer structure, so you can select all this element, and in the tool menu bar you can see this is the mirror option. So you can define their normal vector xyz positions. Like here you can see this is the xy, this is the xz, and then you can define the distance between the layers. So here you can see this is the 2 angstrom. Then you can enable this option. Then you can apply. You can see this is the double layer graphene nano ribbons.
So currently these two layers are parallel. Is it possible to rotate one with respect to other?
Yes, we can rotate. So if you want to rotate, you can select that layer, then go to this rotation option. So here you can see this is the rotation along screen vector, along xyz axis, along abc vector. So I am selecting this along screen vector. You can define their angle, like this is the 1.1, and then you can select the direction. Here you can see this structure has been rotated.
Excuse me, sir. Sir, can we add a layer of a different material?
Yes, ma'am.
Can we add a layer of a different material to this structure?
Yes, ma'am. Different material you can also generate there is multiple layers. And if you want to move any atoms, like if you want to move this layer you want to move, you can select and then go to this move option. View. You can define the distance and either right side, left side, up and bottom, any side you can move. Here you can see this left side has been moved. So anywhere you can move your layer from this move option. And if you want to replace any atoms, suppose if you want to replace these atoms with another atoms, so you can select, and this is the replace atom option. So from this periodic table you can select any element, like this is the boron, select this, okay. Here you can see the boron has been, carbon has been replaced by this boron.
It is replaced in both the layers, no? Is it
Because I have
possible that
selected, yes.
is it possible that we can create a heterostructure like a different two different materials?
Yes, if you want to create a heterostructure for any semiconductor 2D materials, so first you can import that materials. So if you want to create a heterostructure between the gallium arsenide, aluminum arsenide, so here you can see this is the import option. I can import that materials. This is the semiconductor. This is the aluminum arsenide. Again, I can import the gallium arsenide. Here you can see this is the gallium arsenide. So for making a supercell structure, complex structure, you can go to this build option, select this redefine crystal, and here you can redefine your crystal in any direction. So I would like to increase 2 times in the direction of A, 2 times in the direction of B, and 4 times in the direction of C. Here you can see this is our complex structure. And the same things you can do for this gallium arsenide. So again, you can select this build option, select this redefine crystal, redefine this crystal 2 times in the direction of A, 2 times in the direction of B, and 4 times in the direction of C. And for making a heterostructure between this gallium arsenide and this aluminum arsenide, you can select this build option, select this interface filter. Here you can see this is the structure A and this is the structure B. So in this structure A, I can select this aluminum arsenide. In this structure B, I can select this gallium arsenide. You can define their grid size, n range, m range. You can also define their rotation. You can define their strain value, and then you can click on this match option. Here you can see this is the number of atom versus mean absolute strain. graph. So you can see this is the heterostructure between this aluminum arsenide and gallium arsenide. So here you can see total number of atoms. This is the angle. This is the rotation. This is the mismatching value. So this is the extent for surface. This is the second surface. You can match. This is the second surface, and this is the both stand for surface and second surface both. So as per your need, you can increase or decrease the number of atoms. You can preview, and then you can click on this build option. And this is the nanotube.
Sir, can you please fold this heterostructure?
In which direction you want to fold?
Just like you can fold up to 30 degree.
So this is the 30 degrees. And which direction? Like this is the rotation along counterclockwise y-axis. This is the y-axis for the clockwise. This is the x-axis, and this is the z-axis. So it's up to you in which direction you want to move. So any direction you can select, and then you can click on this cancel option. So any direction you can move like that.
It's a rotating or folding. Like I just want to fold this whole heterostructure sheet.
So this is the rotation option.
No, I just wanted to know folding. Like I want to check the flexibility of this heterostructure. So just want to fold this. Whatever you have told initially. Through nanodical option, I think you told that this is different from quantum ATK.
So this is just a bending option. Like here you can see this is the structure. First, I can create this structure into this device. I can define their electrode. So here you can see only two electrode is possible, left electrode and right electrode. I can define their electrode value. This is the left electrode, this is the right electrode, and this is the center region. And then go to this build option, and this is the bending of device structure. So here you can see this is the one-sided, both sided. You can define their theta value and radius value. So rho theta phi, as per your need, you can rotate. Here you can see.
Yeah,
So
it's
this is
nice.
one-sided. And if you want to both sided, here you can see. So in this first session, I have shown you some maximum properties of this rescue software. So if you have any queries, so you can unmute your mic and ask. And the second session will start at 2 p.m.
Can I ask you a question, sir?
Yes, sir. Tell me.
Uh, Before you said if we want to uh, modify the angle, both sides are single side. Which basic data we use for that bending of the angle?
Yes, ma'am.
Sir, can you show the dopants DFT studies how we find here? You will show only SiO6.
Yes. If you want to create a doping,
Suppose why doped ZNO some dopants, how you calculate, sir?
so here you can see this is the doping option, virtual crystal approximation.
Wait, sir. One second, you show me, sir, please.
And
We
this
go for
is
build.
yes, ma'am.
Next.
So this is the p-type doping and this is the n-type doping
Okay,
and
sir.
their value.
Hmm.
And if you want to mix any atoms, so here you can see this is the mixer atoms, this is the arsenic, and this is the gallium. So this is for my structure, gallium arsenide. You can select this plus option, and from this periodic table you can select
Yttrium.
yes, any mixing atom you can select. Like this is the aluminum, okay, and then you can define their composition
So
value.
in which tab is this VCA calculation? Which tab you selected?
This is the LDA double zeta polarized. This is the PBE double zeta polarized, and you can also define your own database.
No.
This is the UW
Excuse me. Yeah, this VCA calculation, from which tab I can select it?
One second. You can select this simulator, select nanodical, then select this virtual crystal approximation.
ಒಂದು ತಿಂಗಳಲ್ಲಿ ಏನಾದರೂ ಮಾಡಬೇಕು ಬಿಡಬಾರ್ದು.
Use my okay. Okay, sir.
Then you can click on this generate file option. So once you define your parameter, either p-type, n-type doping, mixer atoms, you can define their composition value, and then you can click on this generate file. Then it will be generate their input and output file both.
Sir, composition value means how much we taken from aluminum and like that, huh?
Ma'am, as per unit you can define their composition, but their both the values should be one. Both the composition values should be one.
I understand, sir. I understand. Okay. Next, sir.
Then you can click on this generate file. Then their input and output file will be generated.
Okay.
Here you can see. This is the input file and this is the output file. Arsenic virtual crystal approximation. Arsenic is 0.75. Aluminum is 0.25. So this is the output folder.
Sir, can you show the once again the band structure calculation?
Band structure calculation. So any structure you can select simulator, select this RESCU, then go to this ESCF calculation. As per your need, you can define the parameter first, then you can generate the file, and then go to the simulator, select RESCU, go to the analysis, and here you can see this is the band structure. Also you can generate their input file. So first you can run this scf.input file, then you need to run this band structure.input file, then you will get the outputs. And for plotting the output, you can select simulator, RESCU, select this analysis plot. You can select your location, project location. Like here you can see this is the graphene, this is the RESCU crystal, and this is the result folder. So once your simulation will finished, then you will get the output, and then you can select, you can click on this open, and this is the band structure output.
Sir, we can generate the PXRD powder XRD format of this structure.
No sir, you cannot generate in the XRD.
Okay.
Sir, this band structure, is it possible to modify valence band and conduction band?
Yes, sir.
Is it possible to modify valence band and conduction band?
Yes, you can also study. Like I can show you some property project that I have calculated earlier. You can see this is the conduction band. Here you can see this is our Fermi energy that is located on the middle of the band gap. And this is the top of the valence band. And this is the bottom of the conduction band. So this is our conduction band, this is our valence band, and this is our Fermi energy. So thank you for joining this session. So other queries we will resolve in the second session. And also in the second session, you can do the hands-on.